Okay, we're going to pick up right where we left off last time. Remember, we were finding vertical asymptotes. And today we're going to talk about horizontal asymptotes. This is still all preparation for graphing rational functions. You can see they're not easy to graph because there's so much work leading up to it. Okay, this right here, this is a written explanation of how to find a horizontal asymptote. It's going to be easier for you to hear it though. Okay. Finding horizontal asymptotes is all about the degree of the little polynomial that's on the top versus the degree of the little polynomial that's on the bottom. And it's all about who's bigger. That's really it. Except for that you have to remember. Okay, so let's start with this first one. What is the degree of the top? Remember, the degree is the highest exponent. So the degree of the top is 1. The degree of the bottom is 1. So the degree of the top and the degree of the bottom are equal. Fair enough? Okay. When the degree of the top and the degree of the bottom are equal, then the horizontal asymptote is the ratio of the leading coefficients. It sounds worse than it is. So the leading coefficient on the bottom is 1. The leading coefficient on the top is 2. So the horizontal asymptote is y equals 2 over 1, which is y equals 2. That's it. Don't worry, we'll practice some more. All right, let's come over to the second one. Okay, first, oh no, don't factor, sorry. It's easier to find the horizontal asymptote if you don't factor it, so don't factor it. The degree of the top, highest exponent, is a 1. The degree of the bottom is 2. So in this case, the degree of the top is less than the degree on the bottom. When that's true, then the horizontal asymptote is just y equals 0, and you're done. It doesn't matter how many degrees the top is less than the bottom. I mean, it could be y equals x plus 4 over x to the 10th plus, x to the 9th, blah, 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 blah. It doesn't matter. The degree of the top is less than the bottom. The horizontal asymptote is at 0. Okay, let's come over to this one. The degree of the top is 2. The degree of the bottom is 1. Remember, the degree is about the exponent. And when the degree of the top is greater than the degree on the bottom, there's no horizontal asymptote. What there actually is what's called an oblique asymptote. I'm not sure if you learn those in pre-calc, in honors pre-calc or not. I know we don't do them in regular pre-calc, but I haven't taught honors pre-calc, so I don't know if you learn them. But oblique basically means like not straight, kind of. If the degree of the top is greater than the degree of the bottom by 1, then there's a line that's a slanted line asymptote. So like that, something like that instead of vertical, or horizontal. Well, I guess instead of horizontal. Okay, so why don't you pause and try these 3 and get back to me and see if you're right. Okay, so remember, for horizontal asymptote, it's all about the degree. So for this one, the degree of the top and the bottom are both 1. When the degree of the top is equal to the degree of the bottom, the horizontal asymptote is y equals the ratio of the leading coefficients. So that's just going to be y equals -2. Okay, let's look at the second one. The degree of the top is 1. The degree of the bottom is 2. If the degree of the top is less than the bottom, the horizontal asymptote is y equals 0. Now we have the degree of the top is 2. The degree of the bottom is 1. So what's the horizontal asymptote when the degree of the top is bigger than the bottom? None. And that's all you got to say. No horizontal asymptote. So now you have all of the pieces you need to make a rational function graph. that doesn't follow the transformation form. So here we go. If you'll notice, this is an entire page because that's the amount of work it takes to graph a rational function. Just the way it is. Hey, you get fewer of them. Okay, so what is the graph of this rational function? The first thing you want to do is factor. And that's what I did there. Okay. The next thing we're going to do is look at the degrees for the horizontal asymptote. It's easier to find the degree from the non-factored form. You could find it from the factored form, really, though, just by counting the x's. X times x would be x squared. X times x would be x squared. So the degree of the top would be 2, and the degree of the bottom would be 2. But it's easier to tell from the non-factored form. So because the degrees of the bottom and the top are equal, the horizontal asymptote is the ratio of the leading coefficients. There are no coefficients, so they must be 1. So the horizontal asymptote is y equals 1. You'll only ever get a single horizontal asymptote in a rational function, or none, but you'll never get 2. Okay, once we've factored, let's see if anybody cancels. Do any of these factors cancel? No. So what that means is no holes, because holes only come from canceling things. So that means that whoever is left on the bottom is making the vertical asymptotes. So the vertical asymptotes are at x equals 2, coming from this one, and x equals negative 2, coming from that one. The next thing you're going to do is find the x and y-intercepts. But see, we've practiced all of these pieces now, so it should be okay. The x-intercept, take the simplified form, if you have one, set the top equal to 0. Oops. So x plus 4 times x minus 3 equals 0. So x is negative 4 and 3. So we have two x-intercepts at negative 4, 0, and 3, 0. The y-intercept happens when you sub in 0 for x. And so everything's going to just turn into 0 except for these last numbers here. And so negative 12 divided by negative 4 is 3. So the y-intercept is at 0, 3. So that's about all you can get for your graph for right now. After that, you just got to make a table and plug numbers in. It's not the most pleasant thing, but you know, okay, it's the way it goes. So I'm going to actually start by graphing the asymptotes. They say to do that to find more points on the graph, but if you can see where the asymptotes are, then you kind of can see what numbers to plug in. So you have a horizontal asymptote at 1. So I'm going to put that in. And you have two verticals, one's at 2 and one's at negative 2. So I'm going to draw those in. And then from there, I'm going to be able to tell, you know, like where I need points. I mean, you know, do I need a point at positive 37? I mean, no, right? Should move that over a little bit. Okay, I'm going to make them dashed. Don't forget to make them dashed, please. Look at that. I love that. Okay. So, and you know what? Let's just put on the points that we already found, because we already have 3 points. We have our x-intercepts and we have our y-intercept. So our x-intercepts are negative 4, 0 and 3, 0. And these are just literal points. So we're counting from the origin. We're not counting from the intercepts. The only time you can do that is if it's like a transformation one like we did on the last video. And then we have the y-intercept of 0, 3. But as you can tell, that's not enough. I don't know what's going on in this graph. Do you? Okay. I mean, I probably have a better guess, but... All right, so what I want to do is sort of assess the situation and decide where I need points. I'm thinking I need a point at negative 1, a point at 1, right? I mean, that sounds reasonable. This is 3, so maybe 4 and 5. And then over on the negative side, maybe at negative 3. That already is negative 4 and negative 5. I mean, I think that seems pretty reasonable. Okay. It does seem like a lot, but it's actually only 6. Okay, so let's just start on the left. So let's go here to negative 5. So if we plug in -5, so we'll plug it in. It doesn't matter where you plug it in, but just from experience, it's easier to plug it in the factored form, generally speaking. But, you know, it's up to you. Okay. So if you plug -5 into the rational function, you're going to get 8/21, or, you know, a little bit more than a third. If you put in -3, remember we already have the value for -4, you're going to get -1 1/5. Then we'll plug in -1 because -2 is where the asymptote is, and you'll get 4. We already know 0, so if you put in +1, you get 3 1/3. 2 is an asymptote, and 3, or you already had the point, that's the x-intercept. You put in 4, you get 2/3. You put in 5, you get 6/7. Just plot the points. That's it. So -5, 8/21. So that's around a third. You don't have to get nuts. So left 5 up like a third. Okay, that's fine. Over -3, down 1 1/5. -1 up 4. Do you see, like, these points are all over the place? Like, you were never going to guess this. Neither was I. At +1, we're going up 3 1/3. I mean, look, it's not even symmetrical. Over 4, up 2/3. Over 5, up 6/7. So just, you know, like less than 1. Okay. Now, I'm just going to take these out where I mark, because those are distracting now. So now let's see what we got going on here. If you feel you need more points to understand what this thing looks like, then you just plug in other numbers. So this sort of looks normal as far as rational functions go. I think that's what's going on. And if we come over to this arm, it looks similar. I mean, it's not exactly the same, but it's definitely not symmetrical, and they often are not. And then we've got this middle thing. Like, what's going on here? So feel free to, like, plug in more numbers. But it's kind of parabola-ish. I hate to even use the word because it's really so not a parabola, but it is sort of U-ish shaped. Oh, that got so bad. All right, I know that is not, that point on the y-axis is not the bottom. So that's why I tried to make it not the bottom. But it's fine. You wouldn't necessarily know that. I actually looked it up because I had to do the calculus to see, because I couldn't stand not knowing. So if you were to graph this on your calculator, that's what it's going to look like. Okay, so there are a lot of work. I would just like you to pause and think about the rest of our lives, you know, the old people, when we didn't have graphing calculators and we couldn't even check it. We just had to graph this, like, blind. All right, so now we have another one we're going to check. Oh, this one, this table looks longer because I put on it the asymptotes and the y and the x-intercepts, so it looks worse than it is. Okay, so first, let's factor. Top is obviously going to stay the same. Bottom is going to be x minus 5, x minus 1. Nothing cancels, so that means no holes. Very good. The horizontal asymptote, that comes from the degree of the top versus the bottom. It's less, so that means there's a horizontal asymptote at y equals 0. I need a new color here. All right, so there's my horizontal. I would like that to be thicker. Horizontal asymptote. I mean, you don't have to put it in now, but I just can't get it on the line. Ah, that's just gonna annoy me. Oh, fine, whatever. Okay. Make that dotted. Okay, vertical asymptotes. That comes from factors on the bottom that don't cancel. So what would make the bottom factors be 0? That would be 5 and 1. So I have a vertical asymptote at 1, and I have a vertical asymptote at 5. Oh, that's not good. When I did this like the first time, like for my version, I did not have this much trouble with the asymptotes. There we go. Just had to zoom in. Okay. Making them dashed. Okay. X-intercept. Take the top and set it equal to 0. If you have a simplified version, use that. So what would make the top be 0? -3. So I know I have a point at -3, 0. I do? Okay. I guess that brings up a good point that we'll get to in just a moment. The y-intercept, plug in 0 for x, and we're going to get 3/5. So 0, 3/5. Oh, that's not -3, that's -2. So sorry. Yeah, -3. I don't even think I plotted it on my graph. No, I didn't. Forgot about it. That's not good. Okay, I know you're going to have a question on that. Just hang tight. Okay, so I have all that information. That's all I got, right? I mean, I literally have no points in the middle section, no points in the left, on the right section. I mean, this is going to be a lot of plugging. Okay, so first, I have the -3 point. So I'm going to go for x is -2. So if x is -2, y is 1/21. This is a case where I really do think it would be easier for you to put it in the factored form, because -2 plus 3 is 1. That's pretty easy. -2 minus 5 is -7. -2 minus -1 is -3. So it's 1/21. I think that's easier than like squaring it and timesing it by 6. And okay. So -2, 1/21. So just a tiny bit above the x-axis. So I think we should do -1 next. When x is -1, y is 1/6. So it's a little bit above the 121. Or 1/21. Okay, there's obviously not going to be anything at 1. We already know the 0. That's 3/5. What's there? It's undefined. So let's go to 2. When x is 2, y is going to be -1 2/3. -1 2/3. When x is 3, it's going to be -1 1/2. So just a little bit above that one. When x is 4, -2 1/3. What's happening when x is 5? Undefined. When x is 6, I'm going to get 1 4/5. When x is 7, I'm going to get 5/6. So that's closer to 1. Oh, I got slipped. And when x is 8, y is going to be 11/21. So that's, that's just about a half, right? Because 11/22 would be a half. So just about a half. Now I have a better sense of what's going on. You're going to learn more about rational graphs and rational functions in pre-calc, and then again in calculus. And I'm going to address this x-intercept in just a minute because I know you've got questions on it. My iPad keeps slipping out of my hands. I kind of messed that up a little bit, but it doesn't peak that much, but I also checked it on my calculator, so I knew it didn't peak that much. Certainly when you're practicing, you want to do this by hand, but you check it on your calculator. You'd be crazy not to. Okay, so graphs never intersect vertical asymptotes. Ever. Okay. Horizontal asymptotes, though, are a different story. The purpose of horizontal asymptotes is really an explanation of end behavior. Remember when we talked about end behavior earlier? So the horizontal asymptote in this problem being y equals 0, really the purpose of that is to say, as x gets really big and as x gets really small, we'll do negative first. Y approaches 0. As x gets really big, y approaches 0. That really is the purpose of a horizontal asymptote, is really to talk about the ends. So therefore, a horizontal asymptote can be crossed by a graph in the middle, but it won't do it at the ends. So this point here, you can see it's right on the horizontal asymptote, and you're probably thinking, what? How could that be? But it can. It just won't do it at the ends. And so that's a big difference between horizontal and vertical asymptotes. Horizontal asymptotes may intersect, or I should say the graphs may intersect a horizontal asymptote, but they will never intersect a vertical asymptote. So probably what this graph is doing is it's crossing the x-axis. It's coming down, and then it must be bending back up. It's probably very, very slight and almost impossible to see on your graph, but that's the kind of thing that you can find in calculus. So calculus, we could find that point even if you can't actually see it on a graph because it's, it's too slight. So that's rational functions. I hope you got some skills now and you can graph.